Hello, everybody. This is the CUDAN Open Lab Seminar on September 19, 2022. And today, it's our greatest pleasure to have Mike Kestemont and Folgert Karsdorp, who will talk about forgotten books, the application of unseen species models to the survival of culture. That there is a kind of unspoken theme going through this semester in our Open Lab Seminar series, which is sort of could be summarized as culture and nature. And you're definitely contributing to that because I think ecology is somehow looming below the surface here. And the other thing which I think would be quite interesting for our audience, both in the room and people who see it later, both of you are not just some people who out of nowhere were published in Science magazine. Congratulations, by the way, I know how hard that is. The thing is that you have done a lot of other work, which is very important for the community of digital computational humanities, using code and stuff like that. And so maybe you can give a little introduction of like basically who you are, because I'm pretty sure you could do better than I do. And so, yeah, in general, the stage is yours. We typically have 40 minutes presentation, 80 minutes discussion. You can take questions in between. You can talk longer or shorter, whatever you prefer. So the stage is yours. Thank you very much.
Okay, thank you very much for that warm welcome. Folgert, do you want to start with introducing yourself?
Yeah, I can, sure. No problem. So my name is Folgert Karsdorp. I'm a researcher at the small research institute called the Meertens Institute. It's an institute in Amsterdam. It's part of the Royal Netherlands Academy of Arts and Sciences. And it's an institute that focuses on studying language variation. So basically dialect variation and dialect change, and also anthropology and ethnology. I'm officially in the ethnology and anthropology department, although I'm not really sure what I'm doing there most of the time, because I'm often working on computational stuff that isn't necessarily bound to anything anthropological or ethnology. It's basically anything that has to do with culture, how culture changes, and I like to study that using some computational means. So in my PhD, for example, I've worked a lot on folk tales and studying how folk tales change and progress over time. I've looked into different methods of extracting important information from these folk tales, like motifs, for example. It's a well-known concept, of course, in folklore studies, and how can we use simple methods, NLP methods, for example, to extract these tiny meaningful elements from these texts, and how can we then find interesting similarities and differences between these tales to make sort of these networks of stories and show how they progress over time. So that's sort of my main research focus, I think, cultural change. And the other one is indeed, and I've been doing a lot on that together with Mike and Ellen Riddell from India University on trying to make programming for the humanities more accessible. So I think it was in 2021 that we finally published our book. It took about 6 years actually to get that published. It was a lot of work. So we published the book Humanities Data Analysis, Case Studies with Python with Princeton University Press. I think it's still for sale, a hard copy, but it's so we released an open access version of that book this year in January. So you're very welcome to have a look at that. It's on humanitiesdataanalysis.org. It's not really hard to find. So the complete book is there with all code, all examples, everything. So I hope that sort of gives an impression of the sort of things that I do. Mike?
Yeah, hi everyone. Wow, that was very eloquent, Folgert. So my name is Mike Kestemont. I work in the Department of Literature at the University of Antwerp in Belgium. I live in Brussels. I teach mainly digital text analysis there. So computational applications in the humanities at large, even. I did my PhD in Antwerp in medieval literature. And I wanted to work back then on computational authorship attribution for medieval literature, because much of this literature is now anonymous, and we would like to know or find out who wrote these beautiful texts. So that's how I encountered computational instruments in my research. Then going on for my postdoc, my research became even more computer intensive. I dabbled a lot with neural networks in the early days. So when deep learning wasn't cool yet, did a lot of machine learning applications there. And then currently, I guess that my main research interest is sort of the sustainability of information over longer stretches of time. And as you will hear in this talk, so in recent years, we've been turning to ecology to find out more about the stability of cultural information over the ages. And in terms of teaching, next semester, I have to teach a course on digital literacy, which is a very broad topic and nobody really knows what that actually means. But I've been reading a lot on information management, etc. in recent months. So that hopefully gives you an idea of my research interests. And together with Folgert, I've been doing also a lot of extracurricular teaching on Python for the humanities. So that's it, I guess.
Nice. Very, very cool. I thank you very much for that kind of background, because it's sort of, I don't know, having one of these ominous weird times papers myself, I very, very frequently encounter this question of like, how did you arrive there? And it's the side information where you said you did early machine learning and stuff like that, right? So it's that combination where it's not like that this happens because you, like, despite you do these things as a side, but because you do that, right? And so I think that is a really interesting sort of notion. So even though these products then tend up to be exceedingly short, there's a premise, everything sort of like goes into, there is like a whole, the iceberg is like 99.5% of like what's going on, right? What's below. Thank you. So yeah, we very much look forward to what you will show us.
All right, we will start then, I guess. For you're going to do the slides, right?
Yeah,
clicking.
I'll click you through it.
Yes. Yeah, okay. Just a second, I'm not used to working with two screens. Yes, there we go. Okay, all set. Yeah, so welcome everyone to this talk. And today we're going to present some work that we co-published a while back with the fine group of people that you see here about this concept of forgotten books. And more specifically, we're going to explain how we leveraged a biostatistical method, a method from ecology called an unseen species model, to estimate the loss and survival of cultural heritage. And we're going to focus specifically on medieval literature, which, as I said, is my own field of expertise. But in fact, we hope to demonstrate that these methods have a far wider applicability than this case study alone would suggest. Now, books, medieval literature, these are, of course, a prime example of cultural production of the thing we call cultural heritage. And there's many things to say about that, but the main point that we would like to start with is we would like to stress that cultural heritage is fragile. It's easy to lose, to forget, easy to destroy. And we're going to demonstrate that using an example close to from where I live, namely the fire of Leuven. And during the First World War, that city was rapidly conquered, in fact, by the Germans, and they burned down the city center in August 1914. This fire also destroyed the central library of the University of Leuven, which is one of the oldest universities in Europe. And here you can see some of the vivid imagery of what that city looked like after that crucial night. And of course, this happened to many more places in Europe during the world wars. But the fire of Leuven played a major role, in fact, in the propaganda against the Germans. So this was even depicted on postcards, etc. Now, tragically, this was in the First World War. And in the Second World War, this happened all over again, and the library was destroyed again. And during this, what you could call traumatic experience, it is estimated over 1 million books were in fact lost to the flames, including many invaluable manuscripts. 1 million books, that's an insane number, and you could call this a mass extinction event for books. Today, the university commemorates this loss by putting on display a number of what they call snow whites. And these are remnants of books from the fire of 1914, which are nowadays kept in glass boxes protecting them. And I think that this is a very powerful image that serves as a good reminder of the fragility of this kind of heritage, especially in a war setting, which is unfortunately a very contemporary thing also. Now, because of the fragility of cultural heritage, simply put, there are many artifacts from past societies and cultures that haven't survived, that are lost now. And this is, in fact, a straightforward issue, but an issue that is a real hindrance across, in fact, all the fields that study the human past, because the historic record tends to be very incomplete because of these material losses. And because the surviving records are incomplete, we often have no clue whether the surviving record is in fact representative of the original population from which they were drawn, from which they were sampled. And this is very dangerous because it implies that our view of the human past could be very biased towards sources that had simply better survival chances. So more generally, the problem that we are confronting is that of under-detection. And at a certain level of abstraction, this phenomenon of under-detection is in fact at work in many fields, like archaeology, paleontology, art history, etc. And here it is often mentioned in the context of survivorship bias. And of course, a very well-known case is that of Abram Wald during the Second World War. That still inspires a very popular meme on social media. So I guess that many of you will have heard about this. I'm not sure whether I have to explain this again, but it depends a bit. What's that?
Some may have not.
Okay, so I can quickly explain this. It's very funny. So in some audiences, everybody has heard about this, and then in other audiences, people are still happily surprised. So the idea is that British airplanes were sent out over Germany to bomb the Nazis in the Second World War. We're going to mention the Second World War a lot, in fact, today. It's sort of the recurrent theme. And many of these airplanes didn't return because they were shot from the skies. And what the Brits wanted to do was to add extra protection to the vulnerable parts of the airplanes. But because there was like a general shortage of steel, they couldn't just protect every place on the airplanes. And Wald, he was in fact tasked with determining which parts were crucial. And he had to look at patterns in the bullet holes of these airplanes, the airplanes that made it back. But Wald, quite counterintuitively, maybe he realized that they didn't have to protect the regions that actually showed bullet holes, because these were the planes that made it back. Rather, what he decided was to protect the regions without bullet holes. And he was hypothesizing that if a plane was hit there, the plane wouldn't have made it back. And so that's sort of the classic case study that people use to illustrate this concept of survivorship bias. However, there's a big difference here between Wald's case and our case study on medieval manuscripts that I'll mention further downstream in the talk. So in the case of cultural heritage, we still have to estimate how many planes, how many books didn't make it home. So the Brits, of course, knew how many planes didn't come back because they knew how many went out or were sent out in the first place. And what we are going to do is to try and estimate how many planes left Britain in the first place, so to speak. And why do we want to do this? We would like to do this because we're otherwise running the risk of underestimating, you could say, the cultural diversity of the cultural production in the past. So today we'll focus on medieval literature, so literature from before the advent of movable type printing press from the 15th century onwards. And in this period, roughly speaking, from the 11th to the 15th century, we see that handwritten documents, or what they call manuscripts, were the primary means for the the sustainable storage and the transmission of textual material. And what we have done, we've worked with longer form narrative fiction, so no shorter text like songs or poems, with an emphasis on what we have called heroic and chivalric narratives, such as, for instance, the well-known stories about King Arthur and his Knights of the Round Table, which was, of course, a hallmark of the international courtly culture at the time. And apart from these more international fashions, like the Arthurian romance, we've also looked at more local heroic traditions, such as the Icelandic sagas, which some of you will know. And this sort of material, you could say, is like the medieval equivalent of the present-day action hero movie. That's one useful way of thinking about this collection of material. So we make in our work a very firm theoretical distinction that I want to stress between, on the one hand, what we call a work, and the work is abstract, something immaterial. And then you also have the material documents, or the actual copies in which a work has been recorded or copied. And often what you see for these medieval works is that they survive in multiple copies. So especially popular stuff like the Arthurian romances, they circulated in more than one copy. And the number of surviving copies, in fact, by medievalists is often treated as a proxy for the popularity, the contemporary popularity of a story. So important for what follows here is that, in fact, we have multiple sightings of a work. And we see that in many cases, a work once existed, but now we know that no copies of it survive any longer. And in our model, this is what we call a forgotten or a lost work. To make that a bit more concrete, we've made this schema. And here to the left, you can see these gray circles. And these represent the distinct works in a medieval literature that once existed. And you can see that each work initially was copied into at least one document, but often there were more documents or more copies available produced of a single work. Now, in the simplest case, like in the first row, you can see that a document could survive, and then it might end up in a repository like an archive, a library, maybe a private collection, etc. So these are the big gray areas that you see to the right there. Some manuscripts, however, they have been completely destroyed, maybe in a fire, or maybe they just haven't been recovered yet. Maybe they just haven't been properly cataloged yet, and we can still find them. But there's also works that we simply don't know of right now. If you look at the examples, for instance, in the second and the fourth row, so you will understand that these are cases of what we call lost works, because all of the associated copies or documents, they have been destroyed or they haven't been recovered yet. The crucial message that you have to take away from this slide here is that you have, on the one hand, these abstract works, the gray circles in the leftmost column, and that these are nowadays, they can be attested in at least one, but potentially more than one document. And these are the little book symbols that you see there in the second column. So as you could see already in the previous slides, often these original medieval documents, they aren't intact anymore. And often only parts of the original book, or what we call a codex, now survive. And these fragments are studied in a branch of medieval studies that we call fragmentology. And what is interesting is that parchment, which is the primary writing material in the medieval period, that was a very durable resource. And because of that, you see that books, parchment books, were in later times often recycled or repurposed. And they were, for instance, cut up into smaller strips to strengthen the spines of books, or they were used as some sort of wrapping material. So we even know of a butcher in Paris who is known to have wrapped the meat for his clients in medieval folios, which is very, very tragic. So I would love to go to that butcher, of course, but most of the books that were recycled there we won't see them back. The most famous example, and we use this a lot in the branding of our paper, is this bishop mitre. And here you see that, in fact, a part of a medieval manuscript was used to stiffen the inside of a bishop's mitre. And the funny part here is that this was, in fact, a pretty erotic romance that was there hiding on the inside of the bishop's mitre. And this is where I hand over to Folgert.
Yes, thank you, Mike. So we know for a fact that many books have not survived, but just how many have been lost has been a mystery for quite some time. So how do you count what is no longer there, right? So to answer this question, we turn to ecology, as already mentioned, where in fact a similar problem occurs. So in ecology, a crucial concept is that of biodiversity. So basically the number of unique species in a given environment. And that's an important number to ecologists, for instance, to monitor the effects of climate change and natural disasters like wildfires. Ecologists measure biodiversity based on observation samples in which they count exactly how many exemplars of each species they encounter. Now, interestingly, they also have to deal with this with bias in their observations. So some animals are just much harder to spot than others, for example, because they're just much better camouflaged. And this picture here it was already showing actually illustrates that quite nicely. So does anyone happen to see the snow leopard in this picture? Just give you a couple of seconds to try to spot it. It's not that small, it's actually fairly big. But it's really hard.
Everybody get it?
Yeah, it's really hard. I'm just going to show you. It's a really nice example. It's right here, and it's looking you in the face, staring you in the face. Can you see the eyes? I don't have a pointer here, but hopefully you can now see where it's located. It's a really nice example because even if we know that a certain animal must be present, it can still be hard to actually observe it. And the crucial insight here is that ecologists face a similar problem as medieval scholars, you might say. So based on a sample, both try to estimate diversity, but because the samples are incomplete, both run the risk of underestimating that diversity. So ecologists in species diversity and medievalists in literary diversity. Now, for ecologists, it's rather obvious that this observation bias exists. So on the one hand, there is the true ecological process that produces the true species diversity. And on the other hand, there's the observation process of the ecologist, which allow them to see only part of the true process. And it's this mixture of an ecological and an observation process that ecologists aim to disentangle. So to correct for their observation bias, ecologists have developed several statistical models, and those are called unseen species models. And these models then try to estimate how many species were not observed based on those that were observed. Now, one of the most well-known unseen species models is the one developed by one of our co-authors, Anne Chow, in 1984. And her Chow-1 estimator is aimed at estimating the number of unique classes in a population. So, for example, the number of unique animal species or the number of unique works in a literature. Now, like most unseen species models, Chow-1 is used to estimate the number of unseen classes, which is often called F0. Now, by adding the number of unseen classes to the number of observed classes, we can quite easily compute the total number of classes, including the ones that were not observed. Now, just to give an example, imagine that we have discovered a snippet from an unknown book. So this snippet has a total of 18 words on it, and it consists of 6 unique words with the frequencies here in the table. Now, based on the snippet, we would like to estimate how many unique words were there in the original unaffected book. Now, to do this, we take the number of observed classes, which is 6, and we simply add to that the number of unseen classes. And that would then give us the size of the original vocabulary. Now, of course, if only it would be that easy. The real question is, of course, how to compute this number, F0. And we believe that for a proper understanding of the results, it's quite important to have at least some intuition about how Chow-1 estimates this F1 number. And in the following slides, I aim to provide some intuition about that. So computing F0 is not really straightforward. So let's first focus on a slightly simpler problem. So can we compute the probability that a word occurs once? Well, that should be relatively easy. So here we simply take the number of words occurring once, let's call that F1, and we divide that by the total number of words in our snippet, so 3/18. And that number then represents the proportion of words occurring a single time in our snippet. Now, and their average relative frequency, let's call that alpha1, can then be simply calculated by dividing this number by the number of words occurring once. Now, there's one issue. So if we will be certain that the snippet represents the entire original book, then these numbers will be accurate. But we already know that it's the snippet. So there's a fair chance that we have not seen yet certain words from the original book, right? So it turns out that to compute this number, this F0 number, so the number of unseen words, we need a way to incorporate the probability of observing unseen words. The question is, of course, how? Now, the key insight, or well, you can also call it a trick, if you will, is not to use the observed counts C, but a frequency class higher than C. So rather than computing the probability of words occurring once using F1, we will use F2, so the number of words occurring twice. Now that might seem a bit strange, but in a way it also makes sense. So let's suppose we find another snippet of the same book containing one new word. Now, if that word is another instance of the word book, for example, then book no longer occurs once, but it occurs twice. Now, more generally, and this is an insight that is based on the work of Alan Turing and his student Good, is that the probability that we have seen a new word C plus 1 times is equal to the probability of the words we have already seen C plus 1 times. So the probability of words occurring once is then equal to the probability of words occurring twice. But if that's the case, then we can compute the probability of unseen words. So for that, we need words occurring C equals 0 times plus 1. So basically words occurring once. And then we need to divide that number by the total number of words. So here we have 3 words occurring once, meaning that the probability of words occurring 0 times equals 3/18. Okay, so we're almost there. So now we can estimate the proportion of unseen words by dividing F1 by n, right? But how do we use this information to compute the number of unseen words? So that requires some algebraic operations. First, note that the proportion of unseen words is equal to the product of the number of unseen words and the average relative frequency of unseen words. So here again, indicated with this alpha 0. Now, if only we had information about alpha 0, if we have, we could simply divide the proportion of unseen words by the average relative frequency of unseen words by alpha 0 to obtain F0. But again, we don't know anything about alpha 0. We just don't have any information about that number. So now what? So we don't know alpha 0, so the average relative frequency of unseen words. But one thing that we do know is that that the relative frequency of unseen words is likely smaller than that of words occurring once. And that's the trick that we will exploit to arrive at an estimate of F0. So if the average relative frequency of unseen words is smaller than the average relative frequency of words occurring once, then the proportion of unseen words, so F1 over n, divided by alpha 0 must at least be equal or greater than dividing by alpha 1. So that is the average relative frequency of words occurring once. And that's actually a number that we can compute. So to do so, we apply the same adjusted count trick as I showed before and compute alpha 1. So we have 2/18 divided by 3. So to compute F0 then, we divide the proportion of unseen words by this number. So that is, we take F1 over n and divide that by alpha 1. And here the estimate is then that at least 4 words are missing. So I'm emphasizing at least, but because our estimate is in fact a theoretical lower bound. And that's actually really crucial for the interpretation of the estimates that Mike will discuss in a moment. So the only thing that we can prove to be true is that the number of unseen words must at least be equal or greater than the proportion of unseen words divided by alpha 1. Now that might sound trivial, but we believe that such a lower bound is anything but trivial. So the way I explained the estimator of Chow here actually doesn't follow her 1984 paper, which derives the estimator using the Cauchy-Schwarz equation. But that derivation isn't particularly intuitive, not to me, and what I heard also not to her, or not, at least not to explain it to a wide audience. So the explanation I actually gave is based on the code-breaking work by Alan Turing during World War II, and it's related to what is known as the good Turing estimate in information theory. So Turing and his colleagues were also confronted with situations in which they had to guess how likely it was that they would encounter an encrypted word that they had not encountered yet so far. And in a 2017 paper, Chow and colleagues provide a really intuitive derivation of the Chow-1 estimator using the good Turing framework. And I think it's really cool to see that the unseen species formula from Chow-1 can be derived on the basis of the work done at Bletchley Park by Alan Turing. Mike, can I give back to you?
Yeah, thank you. So what should be clear by now is that Folgert, in fact, didn't really mention ecology when he was doing the derivation. And in fact, there's nothing specific to ecology about this Chow-1 method. This framework is a very general one. And in fact, you can apply this method to many things. In fact, you can apply it to any hyperdiverse assemblage of types that has been severely undersampled. So that's a very broad definition, in fact, of what you can apply it to. And in the past, there have already been a number of really creative applications of this model outside ecology. Like, for instance, the number of unreported bugs for a piece of software, very cool. Or for estimating dark numbers, like related to drug addiction in criminology, for instance. Also, it should be mentioned, in fact, that it was recently found out that this model had been independently derived already by a Soviet astronomer, Ambartsumian, in 1970. And he used it to estimate the number of flare stars in the Pleiades, which is, again, a completely different application. The only real caveat to keep in mind here is that Chow-1 is a conservative estimator, in the sense that it gives you a lower bound on F0, or the number of types that you minimally didn't observe. And here, as Folgert said, the idea is that an accurate lower bound is in fact more useful than an inaccurate point estimate for these unseen species. Now, we applied this estimator to medieval literature with a team of international collaborators, and we collected something called count data or abundance data for medieval works and manuscripts in 6 languages in 6 medieval vernaculars. We considered 3 continental literatures, Dutch, German, and French, and then 3 insular literatures or island literatures, namely English, Icelandic, and Irish. And this was in fact a pretty difficult task because we are primarily concerned here with works that don't have many copies. So in fact, we use F1 and F0 to establish F0. And establishing these counts, it requires quite a bit of philological precision, so to speak. And because of that, we try to work as much as possible with pre-existing resources or databases that catalog medieval literature, as it survived in handwritten sources from before the advent of printing in the respective language areas that we considered here. And this was in fact a very rewarding exercise in itself, because it's a very unusual and novel way of looking at this literature. Here you can see the diverse team of specialists with whom we worked to cover the pretty broad range of expertise that was required. And apart from the medievalists here, who were specialists in at least one of these literatures, we collaborated with Folgert, who is the expert in computational models of cultural change, and Chow, who derived this famous estimator that we work with. Now, for our medieval data, it's very crucial to separate two things out, namely the loss of immaterial works, or the abstract things that we talked about, and then also the loss of material sources of documents and manuscripts from which that first loss results. And when it comes to the loss of works, in fact, there has been very little prior quantitative work on which we could base ourselves in any way. The only very faint indication that you sometimes have is that authors will refer in their own works to works that for some reason we don't have anymore. This happens only rarely, and probably this is a severe underestimation of the literature that is lost to us now. And it is for that reason that this is pretty much blue sky research for the loss of works. And this is still, you could call it, one of the major outstanding issues in philology. In this context, we must mention a model by Egger and Goot, who derived this model for estimating the loss of works in printed books. And this model is an important precursor to our work, also because it was later identified as an unseen species model. The problem is that their formula requires a parameter for the print run of books. So the number of copies that were initially produced of a print. And that, of course, isn't applicable to medieval manuscripts, which were never bulk produced, so to speak. Here you can see the first result, namely the result for the union of the 6 languages that we considered. So this is the big picture, you could say. So we collected count data, and in the end, we ended up with, sorry, I'm going to kill my email. Yeah. So in the end, we ended up counting 799 distinct works in this piece of medieval literature that we considered. And together, these works survive in 3,648 documents or manuscripts or fragments of them, if you will. If you take the F1 and F2 from this collection, you can use SHA-1 to estimate the F0, or the minimum number of works that we don't know of anymore from this period. And that leads to an estimate that about 371 works were forgotten from that period. And if you want to express that as a survival ratio, that implies that about 68% of the medieval works in this category survived. You can also visualize that in this nice curve. This is a so-called species accumulation curve. And with the blue line there, what you do is you plot the number of works on the vertical axis as a function of the number of documents or manuscripts on the horizontal axis. And this shows you, in fact, how many new works you are likely to find as you sample or you discover more documents. You can see that there's a solid part to the line to the left there, and that is the situation as we can observe it nowadays. Remember, 799 works. And then you have this dashed part to the line. And that line, in fact, offers you a peek into the future, you could say. So it shows you what would happen if we were to continue finding more and more manuscripts, into infinity even. Because this curve, as you can see, is asymptotic. It starts to flatten out at a given point. And that saturation level, and that suggests that originally there were at least about 1,170 works, of which 68% survives nowadays. This previous slide gave you the results for the loss of works, but we were also very much interested in the loss of material documents, the number of manuscripts that were lost from the Middle Ages. And here, in fact, we are on more solid grounds, because there has been empirical work in this area in book history. And most of this work is, in fact, based on medieval libraries, of which the composition is still known. And sometimes that's the case because, for instance, the catalog of the medieval library survives. And by tracking how many of these documents that are mentioned in these catalogs, how many of these still survive, you can indeed simply estimate document loss. And for instance, for the Holy Roman Empire, scholars have estimated that about 7% of the general population of manuscripts has survived into modern times. For higher end books, however, like expensive books, illustrated books with lots of pictures and gold applied, etc., there you're probably looking, for obvious reasons, at a much higher survival rate that could be as high as 20%, which is much higher than 7%, of course. But there are a couple of caveats again here, because first of all, these library catalogs, these little lists, they are pretty rare overall. And secondly, they come from very privileged, for instance, monastic environments. And the problem is that for these reasons, you don't always know how representative these numbers are for the entire population of manuscripts. So it would be very good if we had a method to corroborate these findings, so to speak. And that's, of course, what we have tried with our research. So for tackling this part of the research, we used an extension of Chow's method from 2009. And this method was originally meant to inform field workers. So people who are out counting ecologists on a specific registration campaign. Now, suppose that you have been able to establish F0, or the number of animals out there that you never observed. This extension of the model tries to estimate how many additional sightings that you have to do to observe each of these unseen species at least once. So what we would like to argue is that the number that comes out of this extension, in fact, gives you a good idea of the number of lost manuscripts, especially because you can assume that most medieval works, especially the ones that we don't know of yet, they must have circulated in very low numbers anyways. And our reasoning here is that if you've seen at least once every work, that probably implies that you have seen most documents also. So here, simply put, the question is, how many more documents would we have to discover in the archives, etc., to discover all works, so to speak? And what you're trying to estimate here, this graph is showing that, is the point where the species accumulation curve starts to saturate. So when does the curve start to flatten out? And our result, you can also see there on this slide, has a blue blob there in the graph. And that shows you a distribution for this estimate that we obtained for the original number of documents that existed for these works. And as shown by the vertical line there, this method suggests that originally there were just over 40,000 manuscripts containing chivalric and heroic narratives. And of these, according to these estimates, only about 9% would then survive now. And when this number first came out, I was really surprised. Because that has to do with the fact that we have these estimates, these previous estimates from the literature in book history, and they suggested a survival factor of 7% for non-illustrated vernacular manuscripts for the Middle Ages. And I remember that I was flabbergasted. I found it astonishing that this method, out of the blue, and although it uses a completely different data source, comes with an estimate that is roughly in the same ballpark, namely 9%. So I found that really cool. Now, when it comes to the loss of works, a survival ratio of 68%, in fact, to a medievalist, it doesn't sound that bad, actually. But these results are for the union of corpora, so for these 6 languages combined, and they are very much biased towards these larger literatures, in particular German. If you calculate the survival rates separately for these languages, in fact, you will notice that there are outspoken differences between the languages. And these results are also backed up by other estimators that we applied here. And what we found really striking, if you look at these graphs, is in fact that 2 of the smaller literatures, 2 of the island literatures, Irish and Icelandic, in fact, had a really high survival ratio in comparison to some of the larger, well-known literatures from medieval times, like French literature. And that is really interesting. Maybe I'm going to show these plots here relating to geographic dispersal. Because what is interesting is that in the past, when people were talking about the loss of medieval literature, people have mostly been speaking about the post-medieval factors in this context. And what is in fact interesting here is to look at the geographic patterns in the repositories where these documents eventually ended up and where they are kept. And in the heat maps on this slide here, we've visualized what you can call the diaspora of these sources over the European continent for 4 of the languages considered here: Dutch, English, French, and German. What you can see here is that surprisingly, French and German, they cover a very similar region and an area surface on the map. But what is remarkable is that Middle English texts have not often been preserved on the continent. So for some reason, these texts from England were never able to migrate to the continent. And what we found in our figures is that Middle English, in fact, had some of the lowest survival figures in our data. And maybe migration, or the ability to migrate, is in fact crucial to these survival numbers that we get. More can be said about this, but this is a very puzzling observation. Now, as I said, in general, people have focused on post-medieval factors to explain the loss and survival of medieval literature. So what we know, for instance, what is very important is the preferences of book collectors in more recent centuries. So these people generally preferred illustrated manuscripts, books with pictures, so to speak. So that is one very clear example of a collection bias in this field, of a post-medieval bias, you could say. In our work, however, and the last part of the presentation is about this, we have looked at an additional factor, a medieval factor, that has often been overlooked in this kind of work. And this relates to what we call the evenness of an assemblage. Evenness is, again, a concept that we borrow from ecology, and it refers to the level of equity in an assemblage when it comes to the distribution of sightings of species, or in our case, the distribution of copies over works. What you see in an uneven literature is that there are large differences in the number of sightings or manuscripts across different types or different types of works. There could be a very long tail, for instance, of very uncommon rare works, rare species. And in general, what we know from ecology is that more even populations are generally more stable, more robust in the face of the loss of diversity, for instance, through what they call external forcing, like natural disasters, wildfires, etc. So what you see is that in a more even assemblage, you have more specimens on average for a species. So it's more difficult for a species to go extinct, so to speak, even if you start randomly removing specimens from an assemblage. And evenness is something that you can measure in a number of ways in ecology. We show that here in this slide, where we make use of a mathematical framework called hill numbers. And these hill numbers, they allow you to plot evenness across a variety of what they call diversity orders. And that's a scalar Q here in these graphs. And what you see is that for higher values of Q, the evenness measure becomes less sensitive to rare species. Now, the takeaway message here from this slide is that in all of these curves, so no matter how you calculate this, you see that these two island literatures, Irish and Icelandic, they display a surprisingly high evenness. And this is important because this is an intrinsic property of these literatures. It's a medieval property that makes them more robust already in the first place to the later post-medieval loss of works from these literatures through the removal or the random removal of documents. And why is that? It's very simple, because there's more equity in the distribution of copies over works in these island literatures. And Folgert is going to tell you more about islands, but first I will say something more about islands. Namely, islands are really cool because they have a very interesting place in ecology as well. They are of special interest there. So islands, for instance, are relatively species poor for their land surface, but they often feature a higher endemic species richness than the mainland regions. So it's no coincidence, colloquially speaking, that Darwin's Galapagos, for instance, that these are islands, so to speak. And we know that islands, and this is where it gets interesting, islands also have a higher evenness in species distribution in comparison, again, to mainland regions. So that can have to do often with the lack of predators, for instance, on islands. And this is a very striking analogy between these insights from biogeography and our results for cultural heritage. And the question now becomes whether it is conceivable that islands are also better at preserving their cultural heritage on top of their biological heritage.
Yeah, and that's a really hard question, and the question is also not really straightforward, especially if you look at work in computational anthropology and cultural evolution. So island societies tend to be smaller, and generally this restricted population size makes them vulnerable. So I don't think I have to tell you that the relation and interaction between population size and cultural complexity has been much debated in the literature. So on the one hand, there are people suggesting that there is a positive correlation between population size and cultural diversity. So in their 2010 paper, for example, Klein and Boyd demonstrate that these oceanic islands with larger populations generally have a higher true diversity. And on the other hand, studies like Acerbi et al. From 2017 have suggested that, especially in more artistic cultural production, the relationship between between population size and complexity might be, well, let's put it that way, less clear. And our results seem to add to that latter thought, as our smallest communities seem to have preserved their literary heritage best. It's an interesting insight from recent work that the structure of a population might just be as important as the size of a population. And the idea is that in a population in which many connections between individuals exist, it's generally easier for innovations to catch on. So after all, there are just more opportunities for an innovation to spread. At the same time, however, there's also an increased risk that certain innovations will come to dominate the population at the expense of other cultural variants. And that's an effect that's well known, and it's called cultural drift in the literature. But when the population is more fragmented, so when there are fewer connections between individuals, that effect of drift can be mitigated. So having a more fragmented population lowers the chances of innovations to spread, but at the same time, it also counteracts the effect of drift. And as such, it helps the retention of cultural variants. Now, using some simple simulation models of cultural change, we've experimented with the effect of population structure on the evenness of the distribution of cultural variants. And we use a simple Wright-Fisher model, which in its most basic form simply assumes a fully connected population in which agents are connected to all other agents, and they can either innovate or copy a trait from the population with a probability that is proportional to its frequency. And we then experimented by loosening the assumption of the population being fully connected, while keeping all other parts of the model constant. Now, using these models, we show that the degree of connectivity in a population will also affect the evenness of the distribution of the cultural variance. So higher connectivity generally results in lower evenness, whereas low connectivity produces more evenness. Now, we prepared a little animation here, and that tries to illustrate this principle in more detail. So on the left, we see an animation of the standard Wright-Fisher model. And each little book here represents an individual, and the color of the book represents a specific cultural variant. So in this population, again, all individuals are connected to each other, which means that individuals can copy all other individuals in the population. And in this fully connected population, the effect of drift can be strong, here resulting in a rapid reduction of diversity with only a few, and by now only one cultural variant left. Now compare that to the partially connected population on the right. So here we have a population which has been divided into 4 communities, subpopulations. And within these communities, the same dynamics apply as in the fully connected population. The difference is that there are only a few connections between the communities. And so there's a smaller chance that a variant from another community will be copied and will become dominant. But for the community as a whole, we see that more variants are retained for a longer period of time, and also that a higher cultural diversity and a higher degree of evenness is obtained. You will round up, Mike?
Yep. So almost there. So in the future, what we want to do is basically consolidate this work further. We want to broaden the scope of its application, apply it to other literature and time periods, maybe antiquity, but also to other cultural domains. And the main challenge for us on the long term is to go one step further and not just estimate the size of cultural loss, but also to explain it. So a bit like with Walt's example with the airplanes. Now that we know, so to speak, how many airplanes didn't return, we would also like to explain why they didn't return, why did some works didn't survive, etc. For this, what we have to do is integrate statistical covariates that can help us explain why certain texts survived and others did not. The classic case, for instance, I mentioned it a couple of times already, is these illustrated manuscripts and whether books with pictures indeed had higher survival chances. That seems like a very reasonable assumption. It's probably true, but this has been very difficult for us to prove this in a statistical, empirical way so far. So in conclusion, we are very excited about these results. We love to get your feedback. So especially regarding the survival of works, the abstract things, we have the feeling that we've broken new grounds. And personally, I never thought that we would even be able to begin to answer these questions. For documents, the documentless, I think the results are less spectacular, but in fact, it's very reassuring that we land on estimates that are comparable to these existing estimates in book history. And I think that this will help our method to find acceptance in the more general medievalist community, which isn't always that straightforward. And because of that, we hope to keep improving our models, for instance, by injecting these additional covariates statistically, which will give a boost, hopefully, to the explainability of our results. And in general, we hope to be moving towards some sort of research program where the study of the history of human culture happens under the wider framework or umbrella of ecology, which should be very rewarding, we hope. If you would like to know even more about our work, we can refer you to the small documentary or author explanation video that we put online. We also have a nice website with more information and visualizations. And then finally, we are firm supporters of the open science movement, and all of our code and data are publicly available under a very liberal license. And of special interest to all you coders out there, we also released a dedicated Python software package for using unseen species models. It's called Copia, has a nice little logo with a goat, and has a lot of unit tests, etc. Is available from PyPy. So it should be easy to experiment with these methods on your own data. So feel free to check it out. And that's it. Thank you very much for your attention. We're looking forward to the discussion.
Thank you very much. This is great. So, pause. So this is supremely inspiring, and you're certainly running in an open door in terms of understanding culture as, you know, an ecological phenomenon. And I think there is probably many questions people have. I got a number of them, but I'm not gonna start, I guess. So is anybody else, or should I start? I could also start. So maybe one simple thing, which is you started with imperfect survival, right? And one of the interesting things is when you go down the road of quantification from imperfect survival, it's important to know that it's not only sort of, you know, sort of the tragedy of incompleteness, but often the incomplete state of the objects gives you the most information about, like, you know, how transmission works, what was the shape of the object, who had it in the hand, like what happened in the meantime. And like, so one question I have is, obviously you work with words, works, and you know, sort of documents, which is sort of like a very coarse grade level, one could say. You obviously throw out the structure of the documents, you throw out the material affordances of the document. Is it made out of leather or parchment and stuff like that? But this is often also the starting point. So can you speak a little bit about the relationship of what you're doing? Like what would people who sort of like on a day-to-day basis, like sort of are very close to the object and sort of things like, okay, this scratch was made by Henry VIII. So how do you deal with people like that? Like what would be the ressentiments and the sort of like maybe also the kind of aha effects these people have looking at your work, basically?
Shall I have a go at that, Folgert?
Please.
Could you maybe share the slides, because then I can see everyone better?
Yeah.
So, especially in discussions with colleagues who work with these sources on a day-to-day basis, you often get the reaction. So we tell them, yeah, a lot has been lost. And then they say, we know. And their question is, what did it look like then? What is lost, in fact? And so especially with books, I do think that these new methods that we're experimenting with now are going to give us better reconstructive capacities also, where we can say, okay, this many works were lost, and this is what they looked like. So here are estimates as to what the actual books or specimens must have looked like. So there, I think that the model just has to be improved to get a better explainability. And this explainability is going to buy us credibility, I think, also with the conventional audience of medievalists. So I'm not sure whether that answers your question.
No, it does. I think obviously, you know, this question can never be fully answered, but like, I think it's an interesting sort of, I wouldn't say contention, maybe crevice that opens in the discussion, which like you can see in systems biology where the virologist who sort of stares at one virus all the time, plus the people who look at like the system of all proteins interacting. You know, the question is like how that conversation is to be had, I think is a really interesting one. And so that's sort of like what's behind that question. Mike Tom has a question with our resident physicist.
Yes, thank you very much. And it was really, really nice. Thank you for this presentation. And well, for me personally, as a person who has training in physics and worked a little bit in biophysics, and now I'm here, it is just, well, the sort of thing that should be done. That's one thing. Another thing is just as a matter of reaction. I'm obviously not a specialist in medieval literature at all, but I just wanted to say that for me the surprising part of your answer is actually that how little is lost. That if you woke me up yesterday morning and asked me what is my stupid estimate of how much of medieval literature survives, I would say probably 1 in 10 or something like this. But you show that it is like 2/3 or something like this, which is, I mean, maybe for professional specialists more a natural number, but it is very, very nice to be able to put some sort of number on that. One question which I don't understand and which worries me a little bit is as follows. As far as I understand, more or less, the model you are using to recover the number of lost manuscripts, and I just looked through the original paper briefly while we were talking. It looks like the assumption is that the manuscripts are lost, or the species are non-observed independently of their frequency, so the probability of losing each manuscript is essentially the same, which seems to be well, natural zero approximation, but which is in sharp conflict with all you say about biased selection, about the airplane, about some manuscripts being preserved with probably 7% and others with 20%, depending on whether they are more important or less important. Can you somehow comment on that? Do you have any idea of how to go beyond the equiprobability?
Folgert, you like this question, right?
I like this question. Yeah, no, it's spot on. That's a crucial assumption of the model, of course. So there's this assumption that all works are equally likely to be observed and equally likely to be lost, and that's the basic assumption of Ein Chow. So there's a lot of unaccounted heterogeneity in the data, basically, and we don't account for that, also not in the model. And what happens if you don't do that, at least that's what An Chow showed in a couple of their papers, is that basically makes your estimate more conservative. So the lower bound, as you don't account for this unobserved or unaccounted for heterogeneity, your lower bound will go down, will become even more conservative. So in a way, that's not to worry about, because it's just the lower bound. It's not going to be a point estimate, an accurate point estimate. So we don't have to worry about that. But it's, yeah, if we already know that there are so many different factors that might impact that lower bound, we already know from the start that it's going to be lower than we might want it to be, or there's just, yeah, there's a lot of room for error. And
actually, sorry for interrupting. Actually, the more the more factors you have, the better, because then you can hope that they somehow average each other out and cancel out. But if there are few strong ones, that is the problematic case.
Yeah, I think so. This paper by Eck and Brood that Mike mentioned, I think they make that claim that they're saying, yeah, if you just aggregate all possibility of losing a document, in the end, the net effect will be that of random loss. There's an argument to be made for that, but I also think there are interesting developments that actually try to sort of incorporate this heterogeneity in your data that help to improve your estimates. So Mike was already discussing this idea of adding covariates, and there's a research team, I believe they're in the UK somewhere, that have this sort of generalized Chow method, and they basically approach it as some kind of a regression problem, where they try to estimate the probability of observing something twice or once. And they put it in a simple regression method where you can add all covariates that you want, and by accounting for all these factors, you try to include this heterogeneity, and in fact, your estimates then will become more accurate. That's also what they show. As you add more information to it, it will become more accurate. If you leave it all out, it reduces to the standard Chow-1 estimate, basically. And it's very nice to play with that, and especially in the context of this work. If you then add information about whether documents were illustrated, for example, or where they come from, or just incorporate that all into the model and basically do model comparisons to see which factors actually contribute to making the estimates more robust and more accurate. Yeah, I hope that sort of answers your question. Thanks for that.
Thank you very much. Chico Camargo is next.
Hey.
Thanks for coming.
Thank you, and thanks for this super interesting stuff. I'm here wondering how hard it would be to adapt this to look at the forgotten motifs, tropes, ideas, you name it. Because there's one challenge, which is just having data on that, sure. But my question to you is, do you see any other challenges in adapting this paper really to something like looking at forgotten ideas and motifs, apart from having data on that?
Yeah, so the thing is, you need to be able to count something. So you need types, and the discretization step is very important. So if you can't do that properly, you have to go to other models, and Folgert can tell you more about these models to measure functional diversity, if I'm correct. What I can say is that what I find very interesting is that we think of species as something very simple and clear, something is a giraffe or not. But in ecology, people often have the same problem, like they have two animals and they have to say, is this the same species? And often that can be very hard to tell. And what I see is that in culture, we have a very similar problem. And that's why Folgert has been looking into these other functional species models. So maybe you can say more about that, because that is more applicable to the concept of an ID, maybe.
Depends. Yeah, sure. I think, yeah, but I think you're also referring to the idea of already categorized tropes and ideas, right? Or not? Or can it be something that is defined? Well, at least, yeah. What Mike is referring to is the idea that you can conceptualize categories or categorical distinctions as an endpoint on a scale, where basically the smallest difference between species defines them as a new category. And that's and all species are equally distinct from each other. That's how you have a categorical taxonomy. What you also could do, and those are more recent extensions, is to look into the sort of the attribute distances between species. So if you have a pond with ducks and geese, for example, that should be less diverse than when you have a pond with ducks and crocodiles. But if you have a categorical distinction, you would have a biodiversity of 2 in both of them. Obviously, yeah, there's some room for nuance there. And in these more recent methods, you try to incorporate the functional diversity, basically, and saying that there's less diversity in the first than in the second, and that might be easier to apply to something like that, where it's not as clear how to define the categories. If you just have exemplars with attributes, you could basically try to build it up as sort of a bottom-up approach to estimating these numbers. And you're gonna, in fact, also extend that to, and that's really interesting, I've only recently been studying that, to the unseen functional diversity, basically. I think that's just a really cool concept to even think about. So the unseen semantic diversity, or yeah, that's just mind-blowing just to philosophize about. Yeah, it's really cool.
Can I extend this a little bit, like tickle a little bit more out of you regarding this? So you were talking, basically the diagram you're showing of work, sort of copy, and so on, right? Part like words, stuff like that, is sort of like the upper part is sort of like one thinks about the Ferber hierarchy, right? So there's the idea of the work, there's the actual work, like the sort of like Beethoven symphony, whatever, and then there is the actual sort of like printed version, and then there is some kind of performance of it. So that is sort of similar to that. But so the interesting thing is work is sort of like a super motif, like it's a collection of motifs already, while at the bottom you have words, which is probably, you could say, the atom or the granular entity. Obviously, it's also not true, but like, it's get closer to the granularity. And what Chico was asking for is sort of the meso level kind of stuff. But one can argue already that your model, as you sort of like set it up and the stuff you count, is too simplistic. But it's fine. But you would say, obviously, you need to do something, because the verbs themselves have interrelation, right? So there's this kind of thing where all of a sudden, you can't really say if sort of some verb isn't the combination of 2 other verbs, which then, sort of like has a self loop, goes to somewhere else. So there's one network of works going on, and then there's a relationship between works and copies. The copy themselves may have sort of like some really functional sort of like dependencies, such as like a part of this thing is stuck on the back in the book of something else, and so on. So there is this multi-layer network happening, which sort of may not result in like one light cone into the past, where you then can ask yourself the question, okay, what's the stuff that my flashlight doesn't light? But that light cone itself may be pretty complex. And so that is sort of something where, like, where do you think are your limits? It strikes me rather similar to these people who see a power law based on preferential attachment everywhere, and the other crowd of people who say, like, no, everything is specific. And so the question is, like, where do we operate there? And like, how much do you think your model holds up as people are looking into these complexities? Hard question, I'm sorry.
Yeah, I think the first problem is data always. So just getting this very simple tabular format, it took us a lot of work already. And as you say, you have these 3 structures at the level of works and at the level of manuscripts, but we don't have them in a structured way available. So for the manuscript, for instance, this is now emerging where people start to create like databases of stematology, etc. But it's just really hard to collect this data in especially at a large scale. So that makes it complex, and that's also the reason why we didn't consider any sort of stematology in the model, because we just don't have that information. At some point, of course, we would like to exploit the information better that we have. So something that we don't do, for instance, is look at the date of a manuscript. That would be feasible at some point to start integrating that information to some extent. These more complex network features, they're beyond our grasp currently, mainly because of a lack of standardization in the way these things are distributed electronically. But it would be interesting to look into these network features, because they give you a very good way of measuring distance also between two works, because like in a word net, you can just count the number of intermediary steps, etc. There, as a medievalist, I'm a bit more pessimistic, because I know that the data just isn't available. So at some point that might be really cool, but at this point it's just not feasible, I think. Because there are also big differences in the traditions between languages. So for instance, in Middle Dutch literature, we don't do any stematology, because we typically don't have enough manuscripts to do a proper stemma. If you then go to French literature, they have these huge intricate stemmas, because they have enough manuscripts to actually make a stemma. So there would be also international differences that you would have to solve, I think.
Interesting. Andres Karjus has the next question.
Yeah, I'm actually here. It's great to hand there. Yeah, thanks for the great talk. So I have a question that is very similar to Chico's, and Folgert kind of partially answered that, which is, again, what else can we do with it? And the concrete specific example that we have is from a different field. And you were talking about data, so we have a case that we kind of have data on a very large scale. So we've been collaborating here with people from the Baltic Arts and Media and Film School next door, which is also part of Tallinn University. And we have these fairly large data sets. So for example, we have a television programming data set going back to 1960. We have a film festival data set, which kind of covers most of the world's film festivals and their programs in terms of films in the last 15 years. And incidentally, I've been just talking about the exact same airplane with different people, including Beyune, who's here on Zoom, and then other people in the film school. So when it comes to festivals, we have data on who gets into the festival. So who gets into Cannes and who gets into some village festival in the middle of nowhere. But what we don't know is who doesn't. So there's also there's probably a huge diversity of people who try to get into these festivals, but they're rejected, and we have no idea how many or what kind. We do have all data on the films that do get in. So their genre, language, crew metadata, what else? Country of production and some other things. So based on this picture that I presented, do you think, and I know this is kind of open-ended, but do you think this sort of thing could be applied to our kind of thing?
The nice thing is that you could model these film festivals as film traps. So a bit like with camera traps for animals. So I do it. Yeah, so it's not a joke. So that's how they, in ecology, they do it. It's a trap, and you only see what ends up in the trap. And then there are interesting models that we dabbled with a bit in the past called occupancy models, where you can actually look at these film festivals as traps and look at their attributes and see how these attributes, for instance, would be biased in some ways. So for instance, if you have the date of the film festival, what you could see is whether female directors get higher chances of getting in over the decades, something like that. I'm not a film historian, so I'm just randomly guessing at interesting things here. But so that would be my first reaction. I do think it would be possible. Folgert, do you have a...
Yeah, I think that's a very good suggestion to look at these occupancy models. Because yeah, so the standard application of Chow1, I don't see that work actually, because it's a slightly different problem. I'm not sure. Do you have any recurrence data where you can observe the same individual at a particular film festival or different film festivals?
Yeah, because we know who made the films. I mean, this data is like extremely messy, so there is like it requires a lot of cleaning. But in principle, yes, we know, you know, if a person went to that festival, well, what film, and then went to another festival with a different film.
All right.
We basically have all of that.
And you can enter a festival multiple times also.
The same film may actually end up in multiple festivals.
Yes.
But could one director end up in that festival the year after again?
Yeah, of course.
Absolutely.
Yeah.
It's
And
important.
even better, but not only do we have the traps, we also sort of have the observations of the feeding stations of those animals that don't go to the trap, but at some point need food, which is sort of like, you know, if you don't make it to a festival, your film is sold as a market, on the market.
Yeah.
So there's a different occurrence, sort of like, and obviously, you know, these are films that didn't make it to the festival or were just directly produced for that. So there is actually sort of like different kind of things going on. And what's, I think is, this is something which was tickling me since your talk. Well, let me just bring it up. There's a similarity among all these systems that we're talking about: biodiversity, species, frequency, frequency of birds, frequency of works, frequency of like how many Oscars could win and stuff like that. So they're all tailed distributions, right? So they're all sort of, we're talking about sort of the broad family of probably zip-like distributions, which is sort of like weird when you end up with a flat distribution. I don't know what kind of extreme case this is. But so one of the interesting things, and I thought this immediately when I read your paper, which was basically on day one when it came out, this happens rarely. When you compare the singletons, the ones that appear once versus the ones that appear twice, you're basically comparing sort of the last two data points in a probably sort of tailed frequency distribution. And if it is sort of something like a ZIP for Paula or something like that, these two data points are the hardest one to change because you have to produce a lot of stuff in order to sort of like move one of them, which you know, sometimes happen because you have two copies of a book that has 2,000 sculptures in there or something, then you can move the number 2 point. But what if the key, because if you do that, right, like even if it's a Gaussian distribution, the F0, F1, F2 are still in a tail. And so the key question is, like, there's one thing you cannot capture with your method, which is sort of, it's a little bit like you're looking at the tail of a cow or like the first two suckers on the tentacle of an octopus you pull out of a cave, and then you wonder how large is that animal, like what's the size of it, what's the shape of it. So the question is, how robust is this against not only like the complexities of multi-layer network, but even within the frequency distribution? Like what are you actually, and it's very different if you talk about a Gaussian distribution where on average everything is like 10 times there, if it's a power law distribution where the largest thing is 1,000 times there, or if it's somewhere in between where, you know, some kind of physical limit of preservation may be there. So the question is, like, I would assume that your ecologist friends have encountered exactly this question probably a lot of times, because there's some situation where you have the frequency distribution and there's others where you don't. And so the question is, how stable is this given any frequency distribution?
So maybe just first to stress, CHA1 is non-parametric, so it doesn't make assumptions really about the underlying distributions.
Okay.
Also, in what you have in cultural data is that the singletons and doubletons are often in the majority, if you consider. So actually, when you have the singletons and doubletons, often you've seen a big part of the octopus.
Yeah, exactly. Yeah. Okay. Yeah.
That's maybe an important nuance.
Well, there's not a nuance that you can make. There are some assumptions, of course, behind the model. So most of the frequency distribution that you encounter in ecology follow some kind of a Poisson-like distribution. And I think that's sort of the primary assumption behind the models. The only thing is, and the primary reason why they only look at F1 and F2 is that those are probably the most stable numbers in the Poisson distribution. And that sort of seemed to work. And it's also probably also only true for these numbers that they actually follow a Poisson-like distribution. So that's why they look at these numbers. And as soon as they don't, and you probably have a lot of data where they don't, where you have some kind of an inflation of ones, for example, perhaps because of a collection bias. So some specialist just has a preference for collecting mainly unique stuff, and is not very interested in finding duplicates, for example, and that will result in a collection with a lot of ones, more than you would expect if you just randomly sampled. And so you also need ways to account for these kind of biases. So I think if you don't incorporate that information, the model can break, in fact, and it can there's a real potential danger there that the estimate is no longer a theoretical lower bound, especially when you have this large inflation of F1s, for example. Then you can't prove anymore that that's in fact a lower bound of your estimate. Yeah.
Yes. Thank you very much. This is actually something which here's a style chart in data collection, right? You may have one anonymous Italian. So there's one node that has 50 books that are all anonymous. It's obviously not the same author. Or you have 50 nodes that are called anonymous Italian 1 to anonymous Italian 50. And probably we would assume that how many books the anonymous has made out of these 50 is probably also a tail. But because out of laziness, whatever, people break it into, so there's all of them have frequency 1. So sometimes, and this is quite funny, like if you go to drawing collections in Uffizi or Vienna Albertina, you will have sort of a significant fraction of your stuff is anonymous, just like in the usual case. So that is a really interesting thing, which I think for the audience is quite interesting. Like once you talk about stuff where you don't know who made it and who done it, then that is indeed, we must be very careful about like what is our F1 and F2, right? But again, this is like it's not like a critique on your method, quite the contrary. It's an interesting thing because we can wrap our head around these kind of anonymous material in a much more different way. And you can expect, oh, interesting. Okay, so I have 100 anonymous books. There's probably 10 that are done by the same person. Maybe you should take a closer look, which historically speaking, people look at Michelangelo again before they look at like the 50 anonymous works, right? So that's sort of an interesting thing. Thank you very much. Mila, Oiva.
Yeah, thank you so much. It's super interesting. And as a cultural historian, I couldn't appreciate more this work. It's kind of like, it's really interesting how you are able to somehow estimate the, absent volume of absent data and kind of like how varied that could have been. Maybe as a continuation for Chico's and Andres's questions, well, I have been working in a project in which we study circulation of fake historical narratives or fake medieval narratives in online environment, basically in the Finnish online media and also in Russian online sphere. And I have been in that project, I have been focusing on the Russian online fake histories. And in that project, we used BLAST and for detecting text reuse, so repetition of texts in the online environment. And in that study, it was quite interesting to see that certain kind of like really widely distributed fake narratives were based on a medieval manuscript tale of the bygone years from 12th century from Kiev. And it was kind of like interesting how it was actually based on certain text snippets that have been, of course, first repeated in different manuscripts, then translations, then different copies of printed books and further translations. And then at some point, those have been digitized and now they are kind of like, circulating in all different kinds of online discussions and blogs and so on. So it's kind of like, it was really interesting to see this kind of like one example of like really surviving text and how it kind of like thrives also in this kind of like wide seam of popular culture, how, it is evident that it somehow resonates with the contemporary discussions and fake stuff and all these kinds of things. So I was just kind of thinking that again, I'm not a medievalist, so I'm not kind of like expert on that sphere. But as far as I have understood, in the medieval, at the very beginning of the book circulation and so on, there has been a lot of there has been an important role with the recombination of certain manuscripts in book volumes. So so the kind of like the way we understand a work today was not probably always the same, and also there has been a lot of copying of text of authors from preceding centuries and decades. So in a way, so the understanding of a work has not been always maybe the same as we understand it now. And then I think it was really interesting what you talked about, this using like traps for kind of like trying to understand what has survived and so on. But I actually started to think, or maybe you want to comment, kind of like, would it be also, as you mentioned that in your future work, you would be interested in also trying to see the reasons for survival of certain texts. So what do you think? Would it be somehow meaningful also to look at how the works work in the culture? What are the kind of like, not only the inert features of these texts, but also kind of like maybe some how certain text snippets, for instance, resonate with the culture, within the surrounding culture, and that makes it kind of like more interesting and more probable that people will copy it and reuse it and repurpose it. So I think that this question is not very well defined. It's not very exact, but I'm kind of like, I'm just really inspired by your work. So there are a lot of thoughts in my head right now. Thanks.
Yeah, thanks for your feedback. That's that was a lot of information to process. So yeah, I think that there's one rule, and that's culture survives as it proves useful to someone. And that's why fake news also survives, because it can be an ideological weapon also. Yes, so I can only remember the last question about the diachronic use of this information. And there, I think, yes, that would be super useful. The problem there is, again, how do you measure this and how do you get data on that? So I can imagine that, I don't know, so again, classic example of gender. What I can imagine is that, for instance, medieval manuscripts from female authors in the past decades have gained value, for instance, so to speak. That is something that maybe you could be able to measure also on the basis of auction prices, etc., to get some sort of proxy for the perception or reception of this literature. The problem is that for more historic periods, it might be really difficult to actually come with a quantitative model of how people perceive literature. The problem is that now it requires so much manual labor, right, of historians looking into one specific text and then trying to come up with a hypothesis. This is the kind of research that might be really hard to scale up in the near future. So yes, that sounds really interesting, but here too the problem is probably how are we going to get data on this, and that is so I can only think of like maybe auction prices, which is something that we have for the previous centuries. That could be a start. Maybe you have ideas.
Well, of course, that's the lack of data is, of course, it's always like a problem, and unfortunately I don't have any good answers. If I will get, I will definitely email you and tell my ideas. But in general, I think it's also very important to, in a way, as a historian working on also often with scarce data, or there are always holes and lack of data. So I think it's kind of like important to or you are just forced to think about what you have, what kind of data, and also kind of like what are the meaningful units of analysis there that you can transform into elements that you can measure and also produce some meaningful results. So yeah, but unfortunately I don't have any good ideas right now.
You are quite right, by the way, that our conception of a work has evolved over the centuries. And I think in a minority of cases, it can be problematic. And there you just always have a philologist who steps in and who makes an executive decision. And that is then the data that we work with. But that's also not an optimal solution, of course. But yeah, I think in a majority of cases, we are able to delineate works, even if there have been changes over time. I think only in a minority of cases, it will be an insurmountable problem. In the majority of cases, it's typically clear-cut. That's my hunch. But,
I think there is a really interesting opportunity to say that cultural history, art history, and so on is one process, right? So it's not like, oh, there's like medieval history or there's, I don't know, clay tablets in Uruk and stuff like that. But we can learn a lot from and can make progress from dealing with these kind of things, with the affordances of that kind of information. These corpora are by nature sort of limited. They need a lot of manual labor to get some kind of quantity, but at the same time we get some kind of completeness, right? It's like in classical archaeology at some point, it's kind of within the order of magnitude of knowing all the sculptures in a career. You can do that. As a medieval literature person, we can probably get an estimate of like how many of these things are there, which is obviously hopeless if you want to grasp like how many people wrote something on Instagram or Twitter on a given day. There's a fire hose of stuff coming at you. And so, but I think the inverse is that's just the end of that. So what Mila is talking about, these sort of like, sort of history on the internet, we're using some kind of medieval book. I think, Mila, you are in a much better position to sort of get really good data. Because once you have orders of magnitude more information, these kind of models, they may still hold. You can ask yourself the question, how many tweets are missing about that kind of book, which is the same, same genre of data, same kind of question. And that is sort of something we also now need to do. We need to look at other data sets in order to sort of validate that. And so this is, I think, one of the main reasons this paper was published in Science Magazine and not in, I don't know, computational medievalistics, volume 48, which probably has 10 copies and all the people who read that. So there is a broader applicability, and that applicability is sort of interesting, and it will ping pong. So there will be, not everybody, most of us in this room probably will always work in culture, but some of us may, change and do flare stars and make an important contribution there. Why not? And then they may do Twitter, and then they may do something else. And I think that is a really interesting thing, that we are actually getting at something which is sort of a forbidden word in the humanities, which is fundamental patterns, fundamental phenomena. Because like I hate to use the word law, but there's like some law-like stuff happening here. And this is something which I think we need to wrap our head around, and sort of. There's the twofold question: A, what is the data with which we can do that? And the second question is like, how can we live with that? Because we know there's like for 150 years, people are fighting that kind of stuff, even if it works. And the reason that they're fighting it is because, many of the models that have been proposed in the last 150 years were indeed not that awesome. And now the question is, how do we do that? That is a really, really important point. And text reuse is something where it is applied to medieval sources, it is applied to ancient sources, and it is applied to situations where it's not even quite clear what the date of object is and stuff like that. But you can obviously also do it on Twitter. And and so I think that is a really, really important sort of message, that we all sit in our little cubicles usually in the medieval department or in the English literature department or in the modern communication studies department, but there is a reason that we shouldn't hang out in the same room. That's exactly why we do this kind of seminars. So there's no hands up. And so I have let me come up with a question on the spot. You were at the very end giving a little teaser of copia. of this software. And so maybe we should give you the chance to talk a little bit about like what this can do and what actually, like what's the purpose and what's the, you know, what's the situation we want to call in the category called copia. Maybe you want to talk a little bit about the software, what it does or something.
Folgert, you like?
Please go ahead. I'll add if I have something to add. Sure.
Yeah, let me see where I can share my screen. Oh, I can't. Is that possible?
No, you should be able to. Maybe
I also try.
I need to probably make you a co-host or something. Just give me a second.
Now you can only see my whiteboard, right?
Yeah.
Yeah, no, because
Sorry. Okay. No. Yeah, we can see your Blackboard or whiteboard or whatever.
I know, but that's the only thing I can share. So.
Let me make
check?
Are you a co-host? No, you're not. Just give me a second. Now you're a co-host and you should be able to share.
Yeah. No, I still can't. I'm sorry.
Shall I try mine?
Yeah.
Yeah, settings wise, you're allowed to actually. Yeah.
Ah, okay. Is this me? No, this is you.
No,
Yeah.
this is me. Yeah, so this is basically the package. It's a Python package for doing all kinds of calculations. For doing bias correction of richness in abundance data. So we're basically only focusing on abundance data and not so much on this idea of the traps that Mike already mentioned, and they often call that incidence data. And so the package basically implements most of the methods that Anne Chow and her colleagues have been publishing about in the past, 30 years or so, or even longer, 40 years. So we have, just the basic Chow method, some improved version of the Chow method that incorporates higher level frequencies. So the F3s and the F4s also to try to sort of improve the estimate in terms of stability. It's not always more accurate, but sometimes it actually helps. So this is the bias correction methods from Egge and Brood. They've also been implemented here. The jackknife is a very old bias correction method. It hasn't been proved actually that it works, but we added simply because a lot of archaeologists, I think in the early 90s, have been applying this to their data. So there's an interesting point of reference here. And I think the min sample is a method that Mike already explained in the presentation. So basically trying to estimate the number of documents that you need to observe to find the estimate number of works. There's a nice so it's on PyPy. So you can easily install it if you want. There are not so many dependencies. There's a nice little quick start. Perhaps it's easier to appreciate what it's doing. So here we're basically trying to reproduce part of the analysis for Middle Dutch, if I'm correct. So we have, you basically read in a data frame here. And we have the works and we have the signatures. So the signatures are just sort of a label or a reference for the different works. Basically, what all you need is a list of unique IDs here, and what we use here are just the titles of these works. And then there are just some utility functions to compute the counts over these works. Some basic statistics, so just to compute the F1s and F2s, it's all very simple. Some plotting functionality that also already gives you some nice information about these distributions. But the most interesting part, of course, is if we scroll down to estimating the species richness using the Chow-1 estimate. So there's so it's basically the submodule estimators that has all these different estimators, and there's this sort of main entry point that's called the diversity function that takes some array or some list of counts, and you can specify all your different methods to compute the unseen number of species, of literary works, or whatever you're interested in. So here we are using the Chow-1 method, basically. And you can also directly import the Chow-1 method, and of course that gives you the same result. Here's another example of applying the jackknife estimator. Just a simple loop of applying all kinds of different methods and see how they compare. Right. There's also some algorithm to bootstrap the confidence intervals. There are different ways of computing the confidence intervals, but generally we found that bootstrapping it is the easiest way of doing that. It takes a while, but it's fairly robust. Here's again the minimum additional sampling method. So this is also some nice diagnostic plots. This is again the species accumulation curve. So we already also provide some plotting functionality in the package, allowing you to more easily and rapidly produce these kind of graphs, and also combining the species accumulation curve with the minimum sample method.
There's a question from Mike.
Yeah. No, there isn't.
It is not an urgent one. It is just I thought that maybe later on we can discuss one.
Okay. Yeah, I'm just scrolling through this. Let me see. Yeah, so this is the concept of hill numbers. Mike already mentioned that. So that's basically a way of trying to summarize your data using different kinds of diversity measures. So richness is obviously a diversity measure. We have a biodiversity of 30 animals, for example, but you also have the Shannon entropy, for example, is also considered a diversity measure, and you have something like the Gini coefficient, also called a diversity measure. And the hill numbers allow you to transform all these numbers on the same scale, making it much easier to actually compare these numbers and also to compare different populations of these numbers, because they measure it in terms of the number of entities, basically. So they're all on the same scale as the richness estimate. So that's really nice to work with. I'm not sure if there's also a plot. Yeah, so basically, yeah, this is nice. So here's the hill plot. You have these different orders Q of diversity. At order Q equals 0, you basically have the richness estimate. And at order 1, you have the Shannon, the inverse of the Shannon entropy, of the exponent of the Shannon entropy. And at, I think, Q equals 2, you have the inverse of the Gini coefficient, which makes it really nice to have these nice overview profiles of the diversity in your data.
So if you go down the road and become a cultural ecologist, you will at some point read the one thing you want to have is the hill number plot, basically. And what is quite beautiful, I think, is that you start with a list of frequencies, that's it. And the rest is sort of like in your package. And I think that is sort of something which is, you know, other than like that paper being flashy in Science Magazine or something, this is something which really sets sort of a gold standard of how this should be done, right? Like it doesn't get any more reproducible, including not only reproducing it with the data you have, but basically anybody who has some kind of frequency distribution.
That's absolutely. That's all we need, basically. Yeah.
This is a major achievement. Thank you very much. This is, yeah, I don't know, quite admirable. Maybe we should, Mike, what was your observation?
Well, actually, given that we have like 10 minutes left, there was one more aspect of this story which never came up in the discussion and which I wanted to maybe probe a little bit concerning this difference between more isolated island cultures and everything else. Yeah, and this concept of evenness. One thing I was basically you've done. I'm not sure I completely understood the model you've done with this on the complete graph and then on the block graph with rare connections between blocks, but it seems to make a lot of sense to me. But what I wanted to say is that if you say that your distribution of text is very even, it is definitely good for the preservation of your set of texts. Yes, because basically each of them has many copies and the chance of survival is large. But in terms of well, if you think of innovation, developing culture or something like this, you would probably expect that in a culture which produces lots of new texts, which sort of innovates a lot, there should be a lot of infrequent texts which are, well, sort of recently came up. Yes, so if something is isolated, it's choosing itself for a long time, and everything sort of settles to some constant distribution. While if it is a system which is more open and which has large time to equilibrate, so to speak, because I would expect that texts appearing in, I don't know, in Picardy will be known in Provence in quite some time. Yes, so it might takes quite a lot of time to sort of equilibrate a system like France. Then you would expect them to have many rare texts, and that is sort of a sign that this sort of system keeps innovating. Is it true, or I'm telling some rubbish?
No, it's completely true that these are two sides of the same coin, I would say. We had to watch out a little bit with the way we presented these cultures. Because, for instance, French literature was larger than Icelandic literature in our corpus. It had a higher diversity, but we didn't want to say that this was like a better culture in some way than another culture. So that's not what we wanted to do. We didn't want to measure the quality of a literature in terms of diversity. So the only thing that we wanted to talk about was this, the level of preservation of culture. But of course, what you say is true. It's not because a literature has been preserved really well that it is also a good literature. So that's not the point. So French, for instance, French literature had a relatively elevated loss in comparison to Irish literature, for instance. But it was a literature in very high standing, and they innovated a lot, which is why they had this long tail of experimental works, maybe, that now are lost. So, of course, it's not because there's a higher level of preservation in the literary culture that the so-called quality or so of that culture is higher. So that's not a claim that you can make.
And by the way, is it, well, it's probably the same question about Germany. Is the notion of French culture well defined? Because you have also northern French dialects and southern French dialects, which are not mutually understandable as far as I understand.
So what we looked at was the so-called classic French langue d'oil, and not at the Languedoc. So we didn't look at that mainly because it was too small in production. So we only looked at one specific variety of medieval French. But they're very important is, of course, that you can't define a language in terms of a territory. A lot of French literature was produced in England, was produced in Flanders, even in Germany. So we don't differentiate in terms of location there. And the language itself is the defining criterion, not so much the location. But we do consider also dialects, of course.
But it is Languedoc dialect.
Yeah, specifically. Yeah. We also didn't look at, for instance, Franco-Italian, which is another like special variety of French, you could say. So when we say French, we mean Languedoc.
And with German, is it also a problem, or?
Not so much, except for the border region between Dutch and German. So there's a couple of really big authors that are in fact being claimed by the two regions. And so people are still fighting over them. And I don't think anybody will ever win. The fight is just raging on. Yeah.
And for that matter, just to just more technically, how exactly evenness is defined?
So there, I don't know the formulas by heart, so we would have to look that up. So we look at 5 evenness measures. Yeah. So the intuitive way of thinking about this is just the average number of items that you have per category. But if you want to express this in the Hill number framework, there's in fact a whole series of formulas that you can apply. We focus on E3, but for the love of God, I can't remember what E3 exactly was. Maybe Folgert can.
I believe so it's basically the Hill numbers divided by order 0. I think that's the E3 version of the evenness. Yeah, it's the simplest form. And then you have all these variations up to E5. So there's a nice paper. I'm not sure if it's on the reference list, but it should be in the paper by Ann Chow, explaining all these different evenness variations.
Thank you very much. 2 hours are almost gone. I'd like to make a point regarding what just happened. For those in the audience who consider this discussion quite esoteric, like how do you define evenness and so on, we just need to remember that in the last, I would say, since Dilthey, right, like 19th century, it's perfectly normal in the humanities to talk about averages, types, right, categories, and so on, which all assume some kind of average. And so that is sort of something which is fundamentally questioned by this whole notion of evenness, because if there is a kind of unevenness going on, like if your Gini coefficient is sort of crazy, if your Shannon entropy is sort of crazy, or to speak in lay terms, if you have a high income inequality, a wealth inequality, production inequality, which everybody knows what this means. That means there's one guy in your street who drives a Maserati and the rest of us walk on foot. And so basically that kind of stuff is something that's normal in the humanities. It turns out, because if you look at the evenness measures, that's actually what's coming out of it. So the key thing is all our intuition that we have sort of like in regular discussions in the humanities goes out the door due to these measures. Like, in my previous work, for example, you find heat laws and Zipf laws and chum size distributions, which are highly uneven. If you look at the, sort of dynamics of ranking in cultural systems, it's some of the most uneven / unstable that you can even find in nature. And so that is another one of these data points. So the fun thing is that there is a twofold kind of consequence coming out of this quantitative work. One is, yes, we can quantify culture. So this is one thing. Yes, something new comes out. But number 2, there is always unevenness in it. That means you need to take a closer look, and it's probably a qualitative look. So people won't run out of work, which is great. It's just there's one more crowd that will join sort of like the enterprise of understanding culture, which is multidisciplinary science people. And with that, I would like to thank you again very much, both you two, the speakers, and the audience, and everybody who sees this later. So we will continue this kind of journey. Thank you very much.
Thank you.
Thanks for having us. Take care.
Bye-bye.
Thank you.
Bye.